In this video, we're going to take a look at question number 3 from the 2011 AP Chemistry free response questions. So in this one, it says hydrogen gas burns in air according to the equation below. Calculate the standard enthalpy change, delta H, at 298 Kelvin for the reaction represented by the equation above. The molar enthalpy of formation for delta H, the molar enthalpy of formation for H2O is negative 285.8 kilojoules per mole at 298 Kelvin. So this is kind of tricky. Don't love this question, part A, but it's very tricky. So if you remember from this unit, since H2 gas and O2 gas are in their elemental state, and this is how they naturally occur, delta H for both of them is 0. So what they want is for you to say, okay, delta H equals the sum of H of our products minus the sum of H of our reactants. So delta H equals our products, which would be 2, and let me write it a different way. 2, the H of H2O, minus our reactants, which would be 2H of H2, plus H of O2. And now we can plug in some numbers. Delta H equals, they say H2O is 2 times negative 285.8 kilojoules per mole minus 2 times 0 plus 0. So this gets a little bit absurd that they're having us do it this way, but don't get hung up on this question. This part A, I don't see AP asking. You know, that was kind of a weird thing in 2011, and I haven't seen anything like it since. So I wouldn't get too hung up on part A. And then in B, it says calculate the amount of heat in kilojoules that is released when 10 grams of hydrogen is burned in air. So now we know that delta H equals negative 571.6 kilojoules per mole of reaction. So in B, we're just going to use some simple stoichiometry. We're going to say we have 10 grams of H2. There's 2.02 grams of H2 and 1 mole of H2. And according to the reaction, 2 moles of H2 will equal 1 mole of reaction. And then according to the delta H, 1 mole of reaction equals negative 571.6 kilojoules. So when I math all of that out, I'm going to get wait, let me plug it in again to make sure. 10 times 571.6 divided by 2.02 times 2. I get 1,415, and this is kilojoules, but since that was negative, you could say negative 1415 or 1415 kilojoules released. Okay, now in C, it says given that the molar enthalpy of vaporization for H2O is 44 kilojoules per mole at 298, what is the standard enthalpy change, delta H 298, for this reaction? Okay, and I don't like their formatting here. AP has gotten better since 2011 at formatting this, so it's very clear what is going on. So let me see if I can make this a little bit better. I've got this. We will use that. And then here, they give us this. That'll be important for us. And the delta H for that is 44 kilojoules per mole. Wait. Actually, hold on. No, it's not. We want to know delta H here. What they said is that the delta H for the vaporization, which would be liquid to gas. So H2O liquid going to H2O gas. Delta H for that is 44 kilojoules per mole. So what we've got to do is use Hess's law somehow to get reaction 1 and reaction 2 to add up to be our overall reaction. So I like to highlight when I do this. We need 2 H2O gas on the right. H2O gas only exists here, and it's on the correct side. So I know I'm going to have to multiply this by 2. And then 2 H2 and 2 H2 is on the right side, and oxygen. And what this will do for us is that'll, okay, so this looks good. So all I'm going to do is take delta H of reaction 1 plus delta H of reaction 2, but I need to multiply it by 2, and that will equal delta H of my overall reaction. I don't love the way that they've worded a lot of this question, but sometimes you get a cruddy question and you've got to work through it. That's just the nature of AP Chemistry sometimes. So we'll take negative 571.6 kilojoules per mole plus 2 times 44 kilojoules per mole. And that will equal delta H for my overall reaction. And when I do that, I get negative 483.6 kilojoules per mole.